pause with the fans. Pause with the pause with the pause with the fans. Pause with the pause with the pause with the fans. Pause with the fans.
I thought I understand this experiment. Please explain it to me. Sure. Chromatography is a way to separate each mixture based on how each component interacts with the phases. Here's the breakdown. There's two phases, which is stationary and mobile. Mobile is like the part that doesn't move, where the paper or the silica gel from TLC, its job is to interact with the mixture, with the molecules in the mixture. Mobile phases is where the solvent, whether it's water or alcohol, move through or over the stationary phases while carrying the mixture with it. I understand that chromatography separates mixture, but which molecule behaves differently? Okay, so here's the thing. As you can see from our previous experiment, lead ink is made out of yellow, red, and blue. And as you can see from this result, the blue dye zoomed ahead of water. It means it is non-polar and it is in mobile phase. While the yellow and the red one is below blue. It means they are less polar or they are polar, where they stay in stationary phase. Oh, how do we measure wings? Is it RF number? Yes, exactly. Scientists use RF values to measure how far each color move and divide by how far the water move. Let's say that it usually a number between 0 and 10, depending on the circumferences of the paper. Example, if yellow in this paper moves up about to 2 cm, the water moves to 5 cm. So the RF value is 0.4. When would I actually use this, especially in daily life? Well, technically in daily life we don't use it because it's more of a lab procedure. But in industry, there's forensic, there's also purity, with checking of purity, like is my medicine contaminated or something like that. Identifying compound, like I said just now, and separate of complex mixtures like plant pigments, like nasi kerabu.
And now I'm going to explain the lab skills for planar chromatography. So for planar chromatography, we have the stationary phase, the mobile phase, and separation. So the stationary phase is spread on a flat surface. This can be paper like paper chromatography or a thin layer of absorbent material on a plate like thin layer chromatography or TLC. And for mobile phase, a liquid solvent, which is the mobile phase, moves through the stationary phase carrying the sample components with it. And for separation, the different component of the sample travels at different rates through the stationary phase based on the properties like solubility and attraction to the stationary phase. First off, it's the sample application. A small spot or strip of the sample is applied to the stationary phase. Second, development. The stationary phase is placed in a developing chamber containing the mobile phase. The mobile phase travels through the stationary phase by capillary action. Then we have the separation, which is the component of the sample separate based on their different affinities for the stationary and mobile phase. And then we have the visualization. If the separated components are not visible, they can be visualized by various techniques like UV lights and staining. And lastly, we have the analysis, which is the separated components are analyzed often by calculating the retention factor, which is the RF value for each spot.
Then planar chromatography also used in manufacturing industry. For example, we use it in pharmaceutical industry to detect the active pharmaceutical ingredient, to test the purity, stability, and the dosage of the drug. It also one of the process to monitor the formulation and do the drug analysis to make a medicine. Other than that, we also use planar chromatography in forensic industry because it can help to identify the sample that we got from the crime area, like ink, liquid, or drugs that can be traced in the sample as a source of evidence. So the investigator can use it to find the criminal. In addition, planar chromatography also used in food and beverage manufacturing industry, because nowadays we have a lot of pollution that can affect our food. So planar chromatography can determine the toxic compound in our food and also detect the contamination in our food. So it can help the industry of food and beverage to produce a healthy and safe product to us.
I will be answering question A and B from our chromatography topic. Let's start with question A. State two limitations of paper chromatography compared to liquid chromatography. For example, high-performance liquid chromatography, HPLC. Answer. Firstly, paper chromatography has lower resolution and sensitivity than HPLC. That means it cannot separate complex mixture well, and it is not suitable for accurate quantitative analysis. Secondly, paper chromatography is slower. The separation process takes longer, whereas HPLC is much faster and gives more reliable result. Now, let's move on to question B. An RF value of 0.998 is very close to 1.0, which tells us that compound X travels almost the entire distance with the solvent front. This means the compound has a very high affinity for the mobile phase, which is the solvent, and a very low affinity for a stationary phase, which is the paper. In simpler words, it dissolves well in the solvent and doesn't stick to the paper much, so it moves far and fast.